Hi, it's Dave. Welcome. Today, I'm joined by Will Summerlin. He is the artificial intelligence at ARK Invest. Previously, he started a AI security startup called Pin.ai, and he is also working in product management at Lyft. So today, I'm super excited. I want to dive into AI. Where is it headed? What's the future of AI? How can investors kind of look at the next 5 or 10 years to find opportunities? So, Will, I want to welcome you on the show.
Thanks, Dave. Excited to be here.
Yeah, can't wait. We've got a lot of excitement regarding this episode. I posted it on Twitter asking for questions. We got hundreds of questions. Just people are really excited to try to understand AI, where it's headed. Personally, I think it's going to be one of the technologies, or maybe one of the dominant technologies that define the next decade. It's one of those, I think, historic type of trends and discoveries. How do you kind of, in the super big picture, like the 100-year or 1,000-year picture, how do you view AI and its significance?
Yeah, so just to kind of zoom out and put this into context, we did some research at ARK and found that the internet likely contributed about $13 trillion to global equity market caps. And we think that within the next 15 or 20 years, AI will contribute about 30 trillion. And so we think that this is going to be, lead to even more value creation than the internet, which is one of the greatest sources of wealth creation humans have ever seen. And so that's just in the very near term. And I think in the long term, AI is going to fundamentally change how humans exist. I think it's on par with the agrarian revolution. If you think way back to when humans went from hunters and gatherers to farmers. And I think the result of that was, when humans didn't have to spend their lives trying to figure out how to stay alive and eat, they shifted to other activities that led to more productivity. And then that led to, the industrial revolution and the technology revolution. And I think that AI is kind of the next big revolution. And so I think that, in even in the near term, in 20, 30 years, the way that we exist as humans will be fundamentally changed by AI. And if we zoom out to hundreds or thousands or 100 or 1,000 years, it's hard to predict, but I think it will certainly be a much different existence than we have now or than we've had in the past.
Yeah, I think one of those themes is kind of what are people going to do, right, with AI? Let's say, improving efficiencies and productivity. Where are jobs going to come from? Where are people going to shift into? We'll cover that later on in the conversation. I think it's a fascinating kind of big trend. Where is society headed? I'm wondering, like with AI, when I look at AI, we have, the whole computer revolution, then right after the internet revolution, and right after now we have the AI revolution. And they seem to all, come one after another and having huge implications. Like, what are you kind of most excited about in terms of, AI, and how is it different than, let's say, the computer revolution and how the internet revolution revolutionized people's lives? Like, is this going to be something that is purveyant, like people are going to feel, the actual revolution, or is it going to be more subtle? Like it's going to improve the back and the processes of big companies and stuff. Like how do you view kind of this rolling out, generally speaking?
Yeah, that's a great question. I think that the promise of AI is that it will do the tasks that humans either don't want to do or just practically cannot do. And I think the replacing and augmenting tasks that humans don't want to do is probably what's going to be most pervasive and present in just people's everyday lives. So, for example, driving cars. Some people enjoy driving cars. Very few people like sitting in traffic and driving to the airport. And so I think those are the types of automations that will come in the short term. I think those are the things that people will see on a day-to-day basis. I think what's actually more interesting, from a sort of macro standpoint, is the impact on tasks that humans can't do. We have limitations with just the knowledge of that the human brain has, and with traditional computers that AI can sort of unlock. And I was on a call this morning with a biotech company, and they were talking about how AI is massively reducing their drug development pipeline, or shortening their drug development pipeline. And so, historically, they had to test, thousands of possible variations to come up with a solution. And now they can actually use AI to narrow it down to the 5 or 10 that they want to validate. And so thinking about healthcare and biotech and the impact there, I think it's going to massively accelerate the development of new products and new technologies I think that's probably going to have a bigger impact on society overall. But the automating things that we don't want to do is probably the aspect that people are going to see most in their day-to-day lives.
Mm-hmm. Like, besides autonomous driving, like what are some things you think that we could see in the next few years? Specifically, like things people don't want to do. It's just a hassle. I mean, first thing that comes to my mind is kind of like delivery, like, going out to get groceries and, all that stuff. So perhaps autonomous driving can, find a way to pick up, the food or the groceries. I mean, what other applications do you think might be out there?
Yeah, I think that's a great one. Obviously, food delivery, shopping, those are things that we don't enjoy that could certainly be automated. I think that thinking about like stuff that you would do, in the context of work. So, for example, accounting. Accounting is something that can certainly be automated with AI, with less error than what a human would do, and more efficiently than a human would do. Contract review is another one. There's actually companies right now that are building technology to automate the review of NDAs and other contracts. So if you're a lawyer, most lawyers that I know don't like spending time in a Microsoft Word document looking at NDAs, and it's very mundane, and that's something that can be automated. So those sort of low-level tasks, I think, will be automated in the short term. And even looking into robotics and robotic automation, things like making a latte. Right now, if you have a cappuccino maker at home, you might enjoy making a latte, but imagine that could be automated and it could be done more efficiently and produce sort of the perfect latte every time. But I think any task that you do that's repetitive is a low-hanging fruit for automation.
Mm-hmm. Yeah. You noted on a tweet, I think, which caught my eye the most, is you said that 1900s was defined kind of as the economies of scale as the advantage for companies. And in the 2000s, it was network effects. And then in the 2020s, you think it's going to be data advantages. Can you kind of expound on that? Like, because these are pretty huge, right? Title shifts, right? It's from economies of scale to network effects, now to data advantages. Like, do you think the network effects that we've seen in the past 20 years, like with social networks, with search, with just, one user adding value to the entire network, do you think those advantages will continue, or do you think somehow those advantages will just kind of be dwarfed by the data advantages in the next decade or two? What are your thoughts?
Yeah, they'll certainly persist, just as economies of scale have persisted. So if you think about the shift from economies of scale to network effects, economies of scale are certainly real. And if you think about, a software company, you can drive down your underlying costs to some degree, your compute and hardware costs, if you have huge amounts of data and huge amounts of compute scale. But the benefits you get from that are sort of marginal compared to the benefits you get from a powerful network, and unlocking that network effect flywheel. And I think the network effects will certainly play an important role in kind of having a data advantage. And just to kind of zoom out and talk about what a data advantage is, basically the idea here is that in the future, the most valuable companies in the world, in our opinion, will be AI companies. They will have AI embedded in their products and services. And generally speaking, with AI, the more data you have, the higher the quality of that data, the better AI models you're going to have. And if you have better AI models, hypothetically, you'll have more customers, and those customers will generate even more data. So you unlock this sort of flywheel effect where you basically create a moat where you have better models, more customers lead to more data leads to better models, et cetera. And you've got to run away, and it ends up in a winner takes most market in many circumstances. And so, the challenge there is data acquisition, and network effects certainly can play a role in that data acquisition. So if you think about, companies now, if you think about the social media companies, for example, they're acquiring a lot of data, and they certainly do have a data advantage. Think about ByteDance and TikTok and the effectiveness of their advertising algorithms. They're so good because they have so much data. And so while they do have that network effect, and that leads to value for the network and for their users, they're also sort of unlocking this data advantage. So I think companies that do have a network effect now, if they play it well, they can certainly develop a data advantage moving into the future. I think another example is a company like Tesla, which has lots of drivers on the road. They have hundreds of millions, if not billions, of miles collected using their sensor system. And so that sensor system is basically compiling all sorts of data huge amounts of data which they can use to train their systems and train their algorithms. And as a result, hypothetically, they would have a more performant system than competitors, which would lead to more customers and more data and so forth.
Mm-hmm. Interesting. You noted also that contrary to common belief, you tweeted that most data is useless or is of little value, but in a few circumstances, data is gold. So, I mean, that's a little bit counterintuitive for most people. Like, how do you kind of wrap your head around that, or how do you explain that there's only certain types of data that are super valuable and a ton of data that just isn't very valuable? Like, how can you help us kind of, how can you enlighten us with that?
So I think there's two ways to measure the value of data. The first question to ask is this data hard to acquire? And so how hard would it be for a competitor to acquire this data? And the second question to ask is how much data do you need to develop really performant algorithms, and where do you reach sort of the data asymptote or the point of diminishing returns? And so to give you like a practical example, at Lyft, we looked at user data, not data about users, but data about users' behavior. So look at things like, okay, if we change a color on this button, will users click this button more? And we got a statistically significant sampling from 100 or 1,000 users. So we didn't need to roll it out to 10 million users to figure out whether changing the color of a button was effective or not. We just needed a very small subset of users. And so I think in those situations where you're looking at just product improvements or other applications like that, you really don't need a lot of data to create value or to understand what you're trying to understand. And so in those cases, after 1,000 users, it doesn't really matter. We could have data from 1 million users, and it probably wouldn't change the output of our experiment. So I think that's one aspect. And then going back to the first one, data acquisition. If it's very hard to acquire data, the data tends to be more valuable. And so in the case of Tesla, it's pretty hard to acquire like that driving data across different roads across the world in different conditions. And I highlighted an example to somebody the other day, which is parking lots in Hawaii. Some parking lots in Hawaii have blue stop signs, and it's I don't think I've ever seen a blue stop sign. But if you're an autonomous vehicle, you need to know that a blue stop sign is a stop sign. And unless you have cars driving in parking lots in Hawaii, you probably don't have that data. And so I think, it is hard to acquire that data, autonomous driving data being an example, where, you need sort of geographic scale, you need people operating under various conditions. The data is constantly changing, so you need to see how roads and conditions are changing. And so the sort of barrier to entry on that data acquisition is relatively high. Mm-hmm. And conversely, if you're just looking at maybe data about driving on a freeway, in a very small sort of geographic region, that data is relatively easy to acquire. You could send an employee out there with a car and drive up and down the freeway a few times and capture all the data that you need.
Got it. I mean, with driving, would you say like the way I'm hearing this is, so let's say driving, most of the data in driving is kind of pointless, useless, too common, but then there are these edge cases or these really difficult, like 1 in a million, like let's say blue sign or just strange object here, or that's the valuable data. Because if you could capture all of that data across millions and millions of points, then you're able to improve, the driving capability of a car in all of those situations. Like, is that kind of one way to kind of understand this?
Exactly.
Okay.
Yeah. So most of the data that you would collect on a daily basis driving around wouldn't be super valuable, but the data from those edge cases is extremely valuable.
Got it. What's stopping, you think, other OEMs, other tech companies from gathering kind of massive amounts of driving data like Tesla does? I mean, could they hypothetically tack on, some cameras and, try to get that data? Can Google, get some cheap Android devices, stick it on windshields, to get 1 million cars, driving around? Like, is that something that you think is there something fundamentally more or challenging about gathering that data than just doing kind of more of a simple, adding sensors or adding a camera?
Yeah, I think there's a couple aspects. So there are some companies that are doing this to a degree. There's Comma AI, that's basically they had built hardware that you can just sort of cameras you can stick on your windshield, and they're trying to collect large amounts of data through that mechanism. But I think that the data collection is one aspect of this, and then actually figuring out what to do with the data is a second challenge. So to talk through both of those, to begin with, to acquire all of this data, as you mentioned, the edge cases, Tesla doesn't want data from you driving on the freeway that they've seen 100 times. That just creates noise in the system. And so, but they do want the data when you see a blue stop sign or when you have to slam on your brakes because the system didn't respond the way you expected it to. And so they want data on those edge cases. And typically speaking, the way that I understand they capture that data is if there is an intervention, it basically captures all the data around that intervention and then sends that data up to Tesla. And so Tesla has a large number of vehicles operating sort of a pseudo-autonomous state, whether it's autopilot or the full self-drive beta users. And they're, in my opinion, ahead of the competition when it comes to users actually operating in a pseudo-autonomous state. Whereas if you look at any of the other legacy automakers, they just don't have as many people that would be operating in an autonomous mode and have an intervention where they had to break it out of the autonomous mode. And so I think that's one advantage that Tesla has when it comes to sort of data capture. I think the second is creating an incentive structure. If a legacy auto manufacturer wants to start putting all these sensors in their cars, it's going to increase the price of the car. And if they don't have a competent sort of autonomous system, why would a user pay an extra $2,000, $3,000, $5,000 for a car with sensors that are kind of useless? And so I think there's some price sensitivity. To your point, a way around that would be to put Android on the dash or something like that. And I think in that sense, there's two challenges. One is it's not going to acquire high quality data necessarily, and the second is again user incentives. Why would a driver just put an Android on their dash for no reason if they're not getting anything out of it? So I think that's the other challenge. And then when it comes to actually making that data useful, that's really where a big challenge is around labeling and around actually continually learning and putting that back into your neural networks and putting that back into your model. And I think labeling is something that is underappreciated, the complexity of effective and efficient labeling. And I think that Tesla has built up a pretty efficient way to capture those incursions, effectively label the data, and then create a feedback loop back into the system so that they can push that out in the next next software release. Mm-hmm. And I think that other companies that I've seen just aren't quite there yet.
Mm-hmm. Can you help us kind of understand a bit like how big and how big of a task is it to not just capture, let's say, all of this data for autonomous driving, but actually to label it, to put into models, to train the models, to test the models, to do shadow mode, like what are we talking about in terms of operations or just the behind the scenes? Like what's going
Sure.
on behind all of that?
Yeah, so Tesla is, from what I've seen, and Andre Karpathy was on a podcast recently, and I think you actually did a breakdown of it, which was really, really interesting. They've gotten a lot better at automating sort of the feedback loop between collecting data from an incursion, retraining the models appropriately, and then pushing that out. And I think they're continuing to sort of automate that cycle. I think historically, I won't speak for Tesla specifically, but historically, the way that it would be done is you would essentially have an incursion. That data would come in and it would say, hey, the system either misrecognized this object or didn't recognize this object at all. And a human would look at it and say, okay, well, actually, that's a stop sign, even though it's blue. And they would label that a stop sign. And then that would probably happen 5 or 6 more times. And then the neural network should be retrained. And then the next time it saw the blue stop sign, it would basically say, hey, this is a stop sign. And there is some more automation going into that process and pipeline. I would expect if we're thinking, 2-3 years out, there will be even more automation. So that feedback loop will require much less human review than it does now or than it has historically.
Interesting. So with Tesla, are kind of been touting or sharing their plans of this Dojo supercomputer. And Elon has said, this is a training kind of supercomputer. Like, how are you envisioning the need for Dojo? Does Tesla really need a training supercomputer? Can't they just go elsewhere to do it? And then what does this mean? Is Tesla getting into hardware, and are they creating a platform for, AI training? Where is this headed in your opinion?
Yeah, it's a good question. So just to kind of zoom out and put this in perspective, I don't know if you're familiar with GPT-3, but just to kind of share GPT-3 as a frame of reference, it's a text language model that's trained on like most of the text on the internet. And so it's about 175 billion parameters, which is massive. So it's trained on like 500 billion words, I believe, from the internet. And so huge amount of data. And the training cost there was relatively high. I think it cost them a couple $1 million, about $5 million to train that model. And it took some time. It's not something that happens instantly. And that I saw an interesting sort of research and interesting thread on this suggested, if you wanted to essentially try to model the human brain using currently available compute technology, the human brain is about 100 trillion synapses or 100 trillion parameters versus 175 billion parameters. So it's absolutely massive. It's orders of magnitude larger. Right now, with current compute hardware, it would cost about $2.5 billion to train a human brain. And it would take a long time. It would take many months, and it would take a huge amount of energy. And using the sort of current cost declines and increases in efficiency in neural network training, if you model this out to the mid 2030s, the early sort of 2032 is the number, it would cost about $5 million. And so there is this sort of push commercially to reduce the costs associated with training huge amounts of data, but it hasn't been done yet, right? It's still something that's in the future. So I think one consideration is just the cost of training these networks. And I don't know what Tesla's current sort of cost structure looks like related to training, but I can imagine that the cost and the time it takes to train some of these really, really complex neural networks with huge amounts of data could be a factor. But I think a second factor that's probably more important is if you control the full stack, if you control the hardware and the software, you can essentially, you can customize your models and customize your hardware specific to the task that you needed to complete. And so if you think about the hardware that an NVIDIA or somebody else is producing, it's great general hardware, but it has to be used across a wide number of applications. It's not just used for full self-driving, for training, visual neural networks for Tesla's system. It's used by other car manufacturers. It's used by crypto miners for stuff there. It's used by other companies for other AI applications. It's used by biotech companies. And so they have to build a model that's good generally, not great specifically. Whereas if you control the hardware stack, you can build a model and build hardware that's great at a specific task. And so I think Tesla probably sees the advantage of going full stack there. They certainly saw it with their full self-driving computer within the car. I think they've seen another sort of vertical integration applications. So I see that as the real advantage here is they can build hardware and they can build software that's very, very specifically designed to do a single task or a single function, and accept the trade-offs of doing that.
Mm-hmm. Do you see Tesla having any advantage over, for example, Google's TPU, TensorFlow, because you have a massive company in Google who's invested a lot of time and energy developing, their own neural net type of training hardware and platform. Is Tesla just being kind of do they just have hubris to try to go against or try to think they can come up with a better solution, or is there an opportunity because Tesla is approaching it from a different angle, like let's say more on vision, like frames per second or real world AI, or what are your thoughts on that?
Yeah, I think it comes back to building hardware for a specific task versus building hardware to do sort of general machine learning or general AI. And I think analogy here is the SR-71 Blackbird that was built back in the 60s, and it was the highest performing aircraft ever created. And in I think it was 18 months they went from concept to first flight, and it broke every record. Right, it was Mach 3. It could fly at 100,000 feet or something like that. And people look at that and say, well, that's insane. Like, how come we can't do that with commercial airliners now? And I think that the reason was it was built for a very specific task. It was built for a very specific purpose and a very specific mission. And they made a huge number of compromises in order to accomplish that. Right? It wasn't comfortable. The pilots had to wear spacesuits. It leaked fuel on the ramp. It had to be refueled in the air, I think 8 times on a single mission. They had to build specially built tanker planes. And so they made all sorts of compromises, but it was able to do this one thing really, really well. And like it was an engineering marvel in that context. And I think that, the same is true to a degree here where, they're optimizing for a specific function and a specific task, which is, to train their neural networks for self-driving, versus building hardware that is generally, general purpose across many different applications. And by doing that, they're able to accept a number of trade-offs, whereas, a Google or anybody else who's building, hardware is probably building it for more general application. And so I think that, because of that, they could probably build hardware that's superior for their very specific task. But if you took their hardware and tried to use it, in a biotech company for some application there, I would imagine it's probably going to underperform what a Google or somebody else is going to create.
Interesting. We've got a few questions from Twitter followers. So Sandeep Sharma says, do you have any insights on Dojo AI as a service and possible use cases and addressable market? And Dalibor Andrin says, what other problems can Dojo solve and how does Dojo compare to the rest of the marketplace? So, you brought up this interesting thing where, if you make something, so specific, in this use case, you can outperform the more generalized solutions. And perhaps, Tesla is leaning in that direction, trying to solve, full self-driving with that. But does that limit their total addressable market if they open up Dojo supercomputer neural net training as a service? Because it's only advantageous in certain cases. And if so, like how big really is that market?
Yeah, that's a great question. So I know you're familiar with our Tesla model and Tesla price target. That's not something we included. We don't. It could be some surprise upside, but it's not something we modeled in there. And I think it's uncertain now. How that's going to play out if they do decide to release that as a service. Where it's going to focus and what that market looks like. I will say if they build a piece of hardware, if they build Dojo very specifically focused on sort of full self-driving, then they're naturally building something that's optimized for handling sort of neural networks in a visual context. And so capturing images and capturing short video clips, and doing things like distance learning and everything else within that context. So there are other applications that would use that. If you think about, drones, for example, drones can use visual systems. Other sort of other transportation systems are visually based. Some robotics and sort of factory automation we've seen are using visual systems. So I think there are other applications that are using kind of a similar approach as Tesla is using for full self-drive. And if they're optimizing for that specific task, then there certainly could be some overlap there. But again, if they're optimizing for that, and then you take it and you try to if you try to use it to train GPT-3, I would imagine or GPT-4, I guess in this case, it's probably not going to be the most performant approach.
Yeah, interesting. So I had this idea I wanted to toss out to you, and I have no idea if it really what the market or the demand would be. But could Tesla release kind of a API service? And it's probably not obviously going to be the whole that's not the whole web service or neural net training as a service, but just let's say it's a minor feature. But what if Tesla had an API where you could send it pictures or video, let's say a video stream, and it sends back basically everything identified in those streams, but not just objects. So it's not just objects, but it's also the distances, between all the objects. So they use their whole, kind of pseudo Lidar, object distance recognition, all that stuff. So they completely decode, the image, but also let's say it's a live stream video, even who knows, but some type of API where it shoots it back, but it's completely decoded. Is that something you think that has demand at all? Or is it more other companies will just develop that part of it themselves and then add on, other things for their own use cases? I don't know, what are your thoughts?
So if you think about Tesla's sort of strength in this scenario, I think there are certain things in that example that they would be good at. I would imagine they're probably better at distance recognition from a video clip than than other systems or other algorithms. It's kind of interesting that Elon tweeted that they're going to drop radar and move to a camera only system. That would suggest to me that they're probably pretty confident in their distance calculations and distance recognition from a video stream. I would say that there are other things that they're probably not great at right now, given their current data set. If you want them to identify a piano in an image, maybe a Tesla seen a piano on the road. That would certainly be an edge case. But I would imagine that that's probably not where their strength is, and it comes back to that data advantage and those data assets. And they have seen a lot when it comes to driving and road conditions and blue stop signs and all of that. But they haven't seen that's a very small percentage of all objects in the world. And so if you send them a video stream of somebody playing a piano, they might be able to tell you that piano is 5 feet away, but they probably, with their current data set, probably can't tell you that that's a piano. That could change, obviously, as they get more data. If they wanted to train a more general model and sort of ingest all the text and image pairs from the internet, I would imagine they could build a performance system. But it's just a question of is that the direction that they want to go, or do they want to sort of stay focused on the application of full self-driving and maybe release certain sort of certain features like the sort of distance recognition or distance calculation.
Mm-hmm. Interesting. So Elon Musk tweeted recently that like they're planning a Tesla AI Day in late July of this year, and then he also says that he thinks Tesla can become one of the largest AI, or at least shallow-minded AI companies in the world. A play on DeepMind, right? But yeah, I mean, my impression is like folks in the AI world, like generally speaking, like this is a pretty, this is very, I guess, capable / there's a lot of, credentialed high, level people in this AI world, PhDs, running around. Google is the ultimate probably public company who has, the aggregation of a lot of these minds. And my impression is like, Tesla is not in the conversation of the top AI companies at all. I mean, it's just Tesla's way out there. So for Elon to actually insinuate that Tesla could be an AI company, but could become one of the largest AI companies, it seems like it's a really, really crazy out there statement. How do you interpret that statement? Is it something that is possible, or I mean, and like, how big can their AI aspirations become? Like, is it just going to be, you think, full self-driving, or is it something that, like, do you think Elon or Tesla has something potentially much bigger, in play or in mind?
Yeah, I mean, Elon certainly doesn't lack ambition, and so I'm sure that he has a bigger vision in mind. And I think to the points that you made, is two thoughts. First, within the sort of AI research community, it's very, very kind of academic and research oriented, and very rarely do the big breakthroughs happen, in a very academic setting. And so I think that the fact that Tesla is not associated with that world, could be a good thing. And I think that the AI. To the second point, Tesla is one of the few companies that's really deploying AI at scale currently. If you think about sort of the complexity of full self-driving and the amount of data that's required, and the just the complexity of the neural networks and the systems, it's daunting. It's mind-boggling. And so, I think Tesla has sort of proven to the world that they are competent and they are capable of developing, really complex systems, AI systems. They're capable of operating at scale. And I think that's something that in and of itself is really interesting and a positive signal that they could be building something that's more broadly applicable than full self-driving. Just based on what we've seen so far, I think that their focus seems to be leaning towards full self-drive. And I think that, it could change in the near future, but that's kind of where we're looking right now. And to Google and to DeepMind, it's interesting because they're kind of on the opposite end of the spectrum. They're doing really, really incredible breakthrough research. If you look at AlphaFold or you look at any of the projects that have come out of DeepMind, it's just mind blowing what they're working on. But it seems like it's still a little bit detached from commercial application. And so Tesla on one hand is like building this stuff in the real world. It's being used every single day by hundreds or thousands or millions of people, whereas DeepMind is working on equally impressive research, but it sort of seems more confined to a lab at the moment.
Mm-hmm. Yeah, it's interesting. I kind of wonder if like Elon will recruit some people. I mean, if Elon thinks Tesla is going to become one of the largest AI companies in the world, it would make sense that he needs some more AI brains, like maybe some of the top in the world. It's going to be interesting. Definitely.
That's the big challenge in AI right now. There are two challenges in AI, and so like from an infrastructure standpoint, neural networks are pretty good. Like we have a pretty good understanding of how to train neural networks and how to manage them and deal with them. There are two challenges. One is data acquisition, and that goes back to sort of the data advantage and data assets. The other challenge is people. It ultimately comes down to people and finding really good, data scientists and AI engineers, and there aren't that many of them. Frankly, there are probably a few thousand really good data scientists and really good sort of data engineers, AI engineers. And there's a huge war to recruit those people, and companies Google will happily pay those people $1 million a year out of a PhD program and give them a great office and a great environment to work on. But I think what I've found in talking to those people is what really motivates a lot of them is working on real world hard problems. And so I think if Tesla can position it as like, hey, come work on real world AI problems today. We're solving the hardest problems. It's applicable here and now. I think that they'll be able to pull some of those people away, in my opinion.
Yeah, definitely. It's interesting. Like I saw your tweet about good AI engineers commanding over $1 million, like even in the early stages of their career. But it reminds me a little bit about like maybe about 10, 15 years ago, software engineers, they're such like the good ones, were getting scooped up by some of the big companies, and they're paying, like a lot of equity and a lot of salary, you could just, and Facebook and Google were in this war. And it's like, I don't think at that time people in the outside realized what was going on. Like they're saying, hey, this is like a great software engineer could do a lot, it's very valuable. Yeah. And it reminds me a little bit right now, it's like a great AI engineer like can do so much. And that's why there's this, this great war for, the great competent folks who could really, I mean, like it's with software too. It's like, one stellar engineer can do the work of many mediocre engineers. And I would imagine with AI, it's even maybe it's more magnified in that, like one stellar AI engineer can do the work of many mediocre probably engineers.
Yeah, to give you an example from Lyft, we had pods of engineers and data scientists and some AI engineers were embedded in those, and they were small. A pod might be 5 or 8 people. And they were expected to produce products or features that would, result in tens of millions of dollars of cost saving or sort of incremental revenue improvement for Lyft. And so if you think about that investment, if you have, 8 people who are going to build a product over 6 months, it's going to result in, a $20 million lift for a company. You'll happily pay those people $1 million a year, especially if they can crank out 2 of those products or 2 of those features a year. And so the cost benefit analysis there is such that, it doesn't really matter if you pay somebody $1 million or $1.5 million. You're going to pay them whatever you have to pay them to attract the best and brightest.
Yeah, definitely. So I want to ask you about your perspective on real world AI. So, Elon Musk has stated to solve full self-driving, Tesla has had to, solve a lot of real world AI problems. And it seems like, in a sense, like they thought, hey, full self, or initially, I think that it feels like Elon thought that full self-driving was going to be easier than it was. He wanted to do this cross-country trip, like, several years ago. And it's proven like they've had to solve a lot of other issues. In your opinion, like, is there a divide that's taking place where you have more of this digital AI world, where you have the social media companies like the Facebooks and then you have, Google and all these other companies using AI in the digital sense to improve digital products, to profile people, improve their ads rates, all that stuff, versus a real world, kind of more of a physical world AI, where you have this combination of hardware and software, and it's more about navigating like vision, etc. Do you see that kind of like dichotomy in a sense, or I mean, how do you view kind of the unfolding of what Elon is calling real world AI?
Yeah, I think that it's interesting. I had a conversation the other day with a former executive at Google, and his thought on it was Alphabet as a company is really good at bits. They're not great with atoms, and that they're really really good at software, and that's just embedded in the culture of the company. That's their history. But when it comes to manufacturing physical products, that's just not necessarily their DNA. And that could change in the future. It could be different, but historically that's been true. Whereas a company like Apple is great with atoms and not great with bits, right? Apple's software is in my opinion, not the best. iTunes is somehow still sticking around, and that's challenging. But they're incredible at atoms. They're great at producing physical products. I love their AirPods, love their iPhones, love all their products. I think Tesla is proven to be pretty good at both. I think they've proven to be pretty good at atoms and pretty good at bits. They produce hardware that a lot of people love, and they produce software that's accomplishing some of the hardest problems in the world when it comes to sort of AI. I think that's a unique blend, and I think there's an advantage to that. And going back to our earlier conversation about owning the full stack and building all the compute hardware as well as the software, I think there's an advantage to having a culture and having a DNA that can produce both. And so I think that, like from a sort of company culture standpoint, I think we're going to see that. I think we're probably going to see more companies that are good at atoms and bits. We're going to see more companies that want to own the full stack and vertically integrate, because when you get into AI applications, there is a distinct advantage to owning the full stack. But I think some of the legacy companies, it's going to be hard. It's hard to transform a culture and a DNA. It's going to be hard for a Google to become good at hardware. It's going to be hard for Apple to become good at software. And I think naturally the people that have historically worked on software will probably lean towards continuing to work on software. The people that have worked on hardware their whole careers will probably lean towards continuing to work on hardware. So to the extent that Tesla can pull from Apple for hardware and Google for software, I think they're in an advantage position. But I think that's probably how it's gonna play out.
Mm-hmm. Do you think Apple has a chance with their potential Apple Car in the future?
Never underestimate Apple. I think they've produced great products in the past and certainly surprised the world. I think it is a self-driving car is very much atoms and bits, right? You have to have the hardware, and you also have to have the software, and that's not easy to do. I think they're coming at it from, obviously it's a very secretive program, so we don't know a ton about it at this point, but from what's been rumored or leaked, they're late to the game. I think that they're at a disadvantage from a battery technology standpoint compared to to Tesla and some of the others. And I think from a software standpoint, companies like Tesla are collecting just huge amounts of data every single day, and every single day their models and their algorithms are getting better and better. And I think Apple said that the rumors were like they're going to produce a car like within the next 5 years or something. Imagine how much better full self-driving is going to be in 5 years, and how much better the battery technology is going to be in 5 years. So I think they're late to the game, and they're certainly at a disadvantage. And even Waymo, Waymo is going to have a lot more data in 5 years than they have right now, and their systems are going to be orders of magnitude more performant. And so if they end up partnering with somebody who has that data, who have those assets, maybe that's a way to sort of jump ahead. But from starting from zero, I think they're certainly coming from a disadvantaged position.
Mm-hmm. Yeah, it's interesting. It feels like if they would have entered the game like 4 or 5 years, like 3 years ago, 2018, released a car at the same time as the Model 3, it would have been a different landscape. But the later it goes, it's just that's how much further Tesla is like going ahead with the data, with the model, with the experience, with all of that. And it's just more and more catch up. And it feels like it could come to a point where it's like, whoa, it's just, you know, it's a kind of a tough one, you know.
Yeah, and going to using network effects as an example, imagine releasing a direct competitor to Facebook 5 years or 10 years after Facebook had launched and had millions or billions of users. It's just it's going to be hard to catch up and sort of operate something at a similar scale.
Mm-hmm. Definitely. What's your take on Lidar? So it seems like there's this bifurcation, this dichotomy of beliefs with full self-driving, where you have one camp that with Tesla, maybe AI, but who believe vision only is the way to go. And then you have the vast majority, it seems like, of other self-driving, programs feeling like either they need LiDAR and HD maps, or at least they think that it's going to be beneficial to add LiDAR, to the mix. What's your take? Is LiDAR something you think is needed for, full self-driving, or do you think that vision alone can do the job?
I think that both can do the job, but I think that vision is probably the better approach. And I say that for two reasons. Number one is just cost and scalability, right? If you need HD maps of everywhere you want a vehicle to operate, and you need LiDAR hardware, that's going to become cost prohibitive, and it's going to limit your ability to scale, across all use cases, across all geographies. And if you think about a car, going back to our edge case scenario, you expect an autonomous vehicle in 10 years to be able to pick you up in downtown San Francisco and drive you to San Jose. And along that journey, there's a lot of complexity and a lot of edge cases. You also expect it to be able to pick you up at the Grand Canyon and drive you to Las Vegas. And if you think about just the sheer number of roads that exist in America and around the world, imagine trying to develop HD maps of all those roads, and then if you factor in the cost of actual LiDAR hardware, it could become cost prohibitive. So I think that's the first challenge, is sort of scalability. I think that the second challenge is, I wouldn't say this is a challenge as much as it is just an opinion. Going back to that atoms and bits conversation, I think if you're good at software, you don't necessarily need the LiDAR, right? If you have visual systems, if you have camera systems that can, accurately predict distance and depth, and you have really good software, you probably don't need that LiDAR as much. Whereas if you don't have that software, if you don't have the autonomous systems that are able to do that, you probably are going to lean on hardware a little bit more. And so I think that companies that are using LiDAR currently, one opinion would be that it's kind of a crutch. It's a hardware crutch because they don't have the software. There's a gap in the software, and they're trying to fill that gap with hardware. And I think in the short term, that could work. Like if you look at Waymo's experiments in Phoenix, like you can go watch a YouTube video. One of my colleagues, Tasha, actually took a ride in a Waymo in Phoenix, and it worked really well. It worked as expected. But that's in a very sort of controlled circumstance. The roads are laid out. They've mapped those roads over and over and over again. And if you try to take that, if Waymo tries to take that and scale it across the country in a year or two, I think it's going to be challenging. And so in the short term, they're filling the software gap with hardware. In the long term, I think that's going to put them at a disadvantage.
Mm-hmm. It's kind of ironic that the one of the best software companies in the world, Google, is like taking a little bit more of a sensor approach versus Tesla, this upstart, going all in on software, vision, and AI. It's an interesting kind of picture here.
I think part of it too is the sort of incentive structure within these companies. I think Elon and Tesla are very aggressive, and they're willing to take big risks. And look, those risks could have not worked, right? Tesla could have invested in full self-driving in this vision-only system, and it could have completely failed. And I think that they've kind of turned a corner on that, and proven that it has the possibility, has the potential to work as they expected. Whereas if you look at Waymo, which came out of Google, I feel like they took a more conservative approach. I mean, they've been working on this for over a decade, and I think a decade ago or 12 years ago, or however long ago they started, it probably did make more sense to use LiDAR. And I think that was sort of an entrenched decision that they made a long time ago. And I think that the incentive structure is such within the company that they're not incentivized to take these really, really bold risks, and bet the company on a vision only system. So I think it was an entrenched decision they made a long time ago that's just sort of persisted.
Yeah, I mean, it's interesting. You tweeted this interesting tweet. You said founder-led tech companies tend to be more aggressive and risk tolerant. They will push the limits and reap the benefits. I mean, it's kind of like what I get from that is it feels like you're saying like, hey, with AI, there's something risky about it or inherently like unknown. You don't know what the exact results are going to be, right? You have to try it out. And for a typical, let's say, risk adverse, company or person, like it's kind of scary. But when you have a founder led kind of, ambitious person who isn't afraid to take those risks and see if those benefits will, be accrued or not, like it seems like AI, if it kind of leans and favors those people, right, who are more ambitious, who are willing to go for it, make a mistake, take some risks. And when you talk about Waymo and Tesla, it seems like, it seems like Waymo took the more safer route, the route that was more well known or had less risks. But Tesla took this very unknown, route. They had to really like take risks, build stuff that hasn't been built yet, for unknown results. Do you think that type of theme is going to be played out over and over with AI over the next decade, where you have kind of AI favoring the companies and the founder-led companies, the ambitious ones who just aren't afraid to see what AI uncovers?
I think so, and breaking that down into sort of the three reasons why I think that's true. Like, number one, you have to be a little bit crazy to be a successful founder. The best founders that I know are a little bit crazy. They didn't want to work at Google. They didn't want to work at Facebook. They wanted to go out and try to build something and change the world and push the limits. They're the same people that get speeding tickets going, 100 miles an hour on a freeway. And so I think that just the personality of those types of people, they want to push the limits. They want to push the limits of what's possible. They want to fundamentally change the way the world operates. And so I think the culture of those companies kind of follows that. I think the second thing is, if you think about a typical sort of corporate structure, an average corporate company in America, and this could be true at a tech company or any other company, the incentive structure is such that for most people, they just want to keep their job. They want to get promoted every couple of years. They want to kind of climb up the ladder, and they want to retire when they're in their 50s or 60s. And there's nothing wrong with that. But in that sort of structure and in that organization, you're incentivized to take as little risk as possible, right? You want to do just enough to sort of prove your value, prove your worth, but you don't want to take these big risks. And I think that that's true all the way up to the C-level. And so the people that are working on these problems day to day in sort of larger organizations, they're going to take sort of the lower risk bets and safer bets. And I think this is true even up to CEOs. If you have a hired CEO at a traditional corporation, they want to hit their quarterly earnings. They want to prove that they're, keeping things on track, and they're not really incentivized to take these huge bets. And so I think the sort of decisions with those organizations are kind of constrained by the incentive structure. Whereas at a founder-led company, a founder will just pop into a meeting and say, "Hey, I really think we should do this. It's a huge risk. Let's do it." And that gives everybody in the organization the authority to take that risk. Because if it goes wrong, like you're not, a middle manager is not responsible. It's like the founder said to do it. He said, "Hey, buck stops with me. I'm making the call. Let's try this." And so I think that gives people the authority and the freedom to make those kind of risks and take those bets. And I think third is, as a company gets larger and larger, especially if the founder's not there, it's easy for processes to sort of be put in place, and you sort of add layers of bureaucracy and review, and the entire organization orients towards like minimizing risk. And so I think I saw a video for Mercedes announced their new EV. There were all sorts of, it was a tweet, and it was like comparing kind of Tesla's like, demo day where they were talking about like the Roadster or something like that versus Mercedes. And Mercedes had all the little disclosures on the bottom of the video. And I think that's, you can't read into that much, but I think it's an example of like how bureaucracy plays into it. And I'm sure there were teams of lawyers that watched that, video 100 times and had to make edits and comments. And and add all the disclosures and language, and that's okay. That's the way they operate. But I think as a result, if you want to make a crazy decision, if you want to do something really bold, especially with AI, where you can't explain, you can't necessarily predict what's going to happen or explain to a lawyer within your company like why it's doing something the way it's doing it. I think that they're sort of going to default to no, that's too risky. Let's not do that.
Yeah.
And as a result, they're going to probably wait until somebody else tries it before they decide to move forward.
Yeah, I think what a lot of people in terms of like in the outside world who aren't, let's say, familiar with AI don't realize is this stuff is changing so fast. Like we're still in the early innings. And when a company is embarking on some cutting edge AI project, you don't really know the results. You don't know how it's going to impact the company's bottom line or revenue. It's really unknown because this is cutting edge stuff. It's evolving and changing so fast, and so many different outcomes are possible. And that's why I think it's like kind of fascinating. And it also kind of seems like gives advantage to those who are willing to, swing the bat to get a home run rather than just try to do a single or something.
Yeah. And many will fail, right? If you take risks, it's not taking these bold bets isn't risk free. And I'm sure there will be companies that startups that try these really risky, bold things and fail. But I think what's going to happen is, for every, this is just a guesstimate, but for every 99 that fail, one's going to become $1 trillion company, right? And so I think it's certainly an interesting dynamic.
Yeah. So I want to dive in a little bit more to this real world AI. Tesla is, let's say with their autonomous robotaxi cars, how close do you think they are to solving this? Like, do you think, they just need to plow away with more data and training, or do you think this is still a ways out? Like, let's say at least several years out. What's your kind of time frame?
I think it's becoming an optimization problem at this point. I think they've done the blocking and tackling to solve some of the challenges that seemed insurmountable a couple of years ago. And again, I think that that if they are really removing radar and they're this confident in their camera systems being able to detect distance, I think that's a huge milestone. But I think that at this point, it's really about optimization. It's about getting to they've got 5 nines of reliability and they're trying to get to 8 nines of reliability, and that last little bit, that last fraction of a percent is often the hardest. But I think that's where they're at, and I think they're just working on sort of optimization at this point. And I think they've solved many of the kind of blocking and tackling challenges that they needed to solve in order to build a system that could operate as we expect it to.
Do you think Tesla can take their AI vision experience and just transplant it into a different robot, like a possible in the future, let's say 5 or 10 years down the road, let's say into a household robot, or into like even something like a drone? Like, do you see a drone? Like, part of me feels like a drone is a large part of it is the brains, how the drone will navigate safely and interact with the world around it, and the other part is the hardware. But to me, it seems like the software, the brains is much more complicated than the hardware. I mean, what are your thoughts on that?
Yeah, what I've seen so far from Tesla is that their models are more specialized for full self-driving. And I think an analogy here is like teaching someone German versus teaching them French, right? They're countries that are next to each other. They're both in Europe, but they're different languages. And I think that right now they've taught their cars German, and getting it to fly as a drone would be teaching it French. Not to say that they can't, but I think they have sort of a foundational layer that they can build on, right? If they've solved some of these really hard problems like distance, that could certainly be applied to drones. And I think it comes down to sort of the data advantage in collecting data of flying versus collecting data on operating on roads. So I think they do have the foundations, and certainly they have the learned knowledge of how to build these systems at scale. And if they have the hardware components, right, they have the specialized hardware that's optimized for sort of running these camera-based systems, that could all be transferred over. But I think they would have to retrain probably the majority of the system for a specific task, like operating as a drone versus operating as a car on the road.
Mm-hmm. Do you think, like for Tesla to retrain their let's say their AI for drones to fly and to build an AI, is that more difficult, or is it more difficult for, let's say, like a drone company to gain the AI type of expertise to really be top notch, as good as what Tesla could be if Tesla ported their AI over to, flying?
Yeah, I think a company starting from zero is probably not as well positioned as somebody like Tesla. I think given it goes back to kind of two things in this case. I think one is just talent, right? If you're a startup and you're trying to build an autonomous drone, it's really hard to recruit away those people from Google or Facebook. I think the Tesla sort of has that recruiting flywheel going, and I think that they're probably, and they have the capital to invest, right? If you're a startup, it's hard to pay somebody $1 million a year, but if you're Tesla, it's probably more viable. So I think one is they have a talent advantage, and they have organization where those people fit in, and they can sort of optimize the output of really smart people. And so I think from a talent standpoint, they're an advantage, and they do have the sort of the stack, this AI stack that they can build on. It's both the hardware, it's the sort of probably some of the underlying infrastructure components. It's how they train, it's their labeling infrastructure. All that can certainly be carried over. And I think that the data would be really the main difference, right? They would have to acquire a whole new set of data related to flying versus related to driving, and retrain their models with that data. But I think they would be, certainly in a better position than a startup drone company when it comes to that, if they were willing to invest the resources in it.
Interesting. How about last foot delivery? So this is something I've been thinking about. Is like, let's say a robotaxi or a autonomous car van delivery vehicle comes to your driveway, and there's obviously hundreds of different types of paths where you might be in an apartment, you might be in a house that has a lot of steps, or it might be just in a typical house, or there's tons of scenarios. But let's say in a scenario where a robotaxi autonomous delivery vehicle takes your, let's say, meal or package to your driveway, like how does it get to your porch? Like, do they just dump it on your driveway, or do you think AI will, and combined with robotics somehow, will find a way to get that package or that food or whatever to your door or not? Or do you think, or do you think that's just kind of something where people will just find ways to create lockers or something, where, the vans can just put them, or will people have to go out and pick up, their food or stuff? Like, how do you envision this happening over the next, let's say, 5 or 10 years?
Yeah, that's a great question. I think stairs are uniquely challenging. I don't know if you've seen any of the Boston Dynamics videos on their robots, dealing with objects like stairs. And I don't know, just tangentially, they had a really interesting dancing video. It was a little bit creepy, but I think that's a really hard problem to solve. And companies like Boston Dynamics have been working on that for a while. But zooming out, I think if you think about this in first principles, and you really just want to get a food item from point A to point B, probably a less challenging way to do it is to use a drone. If you have a drone, all you really have to deal with is the takeoff, the landing, navigation, and sort of object avoidance in air, and during the kind of takeoff and landing phase. Whereas if you want to use a vehicle and then somehow use like a smaller robot to go from that vehicle door to door, you have a lot more to deal with, right? You have to deal with stairs, you have to deal with dogs trying to bite the robot, there are all sorts of edge cases you have to deal with, and just like the physical manipulation of that robot would be more challenging when you think about stairs and ramps and everything else it has to overcome. So I think if you're thinking about that in first principles, drones seem like a more efficient way to solve that problem. And I think that's probably going to be the case. I'm sure there are edge cases where robots will be more effective, and I'm sure companies will find those edge cases and try to build for them. But if we're talking about just kind of mass market adoption, I think drones are a more natural sort of vehicle to go from point A to point B in that scenario.
Do you think the public will be accepting of the noise factor with the drones, flying above their heads, or in the sky, like all these drones with packages, Amazon packages and food and all this stuff? Or, I mean, like, for example, like some people, they live in an HOA, and the
Yeah.
HOA could make a rule against, flying drones because of the noise, because of the nuisance. Or do you think, are there some stuff with technology where they'll make it more silent? And I don't know, have you looked into this at all?
Yeah. I think noise will be somewhat of a solved problem. There's a company, Joby Aviation, which is building, trying to build like a flying taxis essentially. And they have a video where their CEO is talking while one of their taxis is taking off behind him, and you can barely hear it. It's almost indistinguishable. And if they're able to do that with a vehicle large enough to carry humans, I would imagine that if you shrink that down into a drone that's able to carry a package from point A to point B, I would imagine that the noise won't be a huge problem.
Interesting. So, Will, I've got like so many questions here, and I feel like it's a good spot to actually maybe cut our interview into part one here, where we've talked about Tesla, we've talked about the foundation of understanding kind of AI versus real world AI, drones, different possibilities going forward. But then there's a whole nother section of questions and thoughts where I want to ask, like, what industries overall do you think could benefit from AI? I want to ask your opinion on companies like Palantir, who are helping companies analyze data using AI, et cetera. And I want to kind of try to get a glimpse of what kind of advantage we can have in terms of the next 5 or 10 years, understanding kind of where AI will propagate and create value. So if you don't mind, we'll go ahead and wrap up part one here, and then we'll go ahead and start a part two for this interview in a few minutes here. Thanks.
Sounds good. Thanks, David.
Cool.